Ken here with you again. AC Practical 16.1, three-phase mesh, and sometimes called Delta. So in this particular prac, don't forget to do your hazard identification, the supervision level, the risk class, and how you're going to control that. We are connecting up lamps in Delta, so they're going to be quite bright because they're going to be across the full line voltage. So it's got a little bit of heat and light generated. You might like to consider that as part of your risk assessment. So here's our circuit diagram, and I'll just turn our pen on. This is our power supply, our three-phase power supply over here. So it's our power source. In this particular case, our power source does happen to be star connected, but we won't be using the neutral, so not connected. We're going to be wanting to measure mostly the currents in each of these phases with our clip-on ammeter. So we're going to be measuring currents, and of course in a delta system the line currents are different to the phase current. So there's our three line currents that we need to measure, and then we'll be measuring each of the phase currents. So that's these ones in here. So phase current, another phase current, and here our third phase current. So that's what we'll be doing. So let's get on and look at our connection setup. So here's our basic setup. You can see here, here's our three-phase supply, and we've got A, B, and C, and we have our star connected lamps. Now the way I like to get students to do this is to actually lay them out so they look like a star, which is what I've done here. And then you can see the red wire just connects those parts together. The white wire connects the start and finish of that together. Then the blue wire connects that and that together. Then it's just a matter of taking your supply and connecting it to a red one. Your white one comes through and gets connected here to the white side, and then finally if you trace through your blue wire you come to the blue. So there's your delta connection, nice and easy. If you go to the trouble of laying out your lamps so it actually looks like a delta, you should have no trouble connecting it. So let's do some current measurements now around our delta circuit by turning it on. And you can see here with my photographs it got very, very bright. And so it's a bit hard to see here on the ammeter, but it's reading about 2.4 or 2.41 amps, and the same over here. You can see it a bit more clearly, about 2.36 or 39. So that's where these readings come from. So our about 2.4 on the A, about 2.39 on the B, and about 2.41 for our line currents. Remember, this is line current, so this is the current coming in on the line side of our delta. Now the next thing we need to do is measure the phase currents. So let's move across to the next slide. And here are the phase currents. And you can see here, I'll just turn the pen on. Here's the red phase being measured. So this is the wire that looped across as that part of the triangle, and you can see carefully it's reading about 1.32. So A phase, which is that one there, reading about 1.32. B phase, being the white one, you can see here measuring 1.31. So that's our B phase. And then finally our C phase here, measuring about 1.30. So you can see there's a considerable difference between the line current and the phase currents. So let's do a comparison. And what I've done here is just 3 tables. The top table is the line current that we measured. So that's the line current that we measured. The middle table is what I expect the phase currents to look like. And I've calculated those. So hence the word calc. So I've calculated those. And of course we're looking for a √3 relationship. So we're looking at our, in this particular case, our 2.43 to be divided by the square root of 3, and that calculates out at about 1.38 amps. And as you can see, what we actually measured was very, very close. So again, here we took our 2.39, we divided by 1.73, which is the square root of 3, gave us about 1.38, and again 1.31, very close, allowing for errors in our instruments, etc. So, and again on the third one, very, very close. What we calculated ended up being very close. So clearly there is a square root of 3 relationship between line currents and phase currents in a delta system. So that's what this prac was all about, making sure that we understand that when we're measuring line currents and phase currents, that we do understand that there is a √3 relationship, particularly in delta circuits. Well, I hope you've enjoyed practical 16.1, again short, sharp and sweet. I again remind you that the values that I got will probably be a bit different to the ones you got, depending on what equipment you have, and that will give you slightly different results depending on the wattages of your lamps and the voltage of your power supply.